Ladies and gentlemen, we present the two-dimensional shapes you've come to know and love in a brand new math story, the likes of which you will never have seen before. Let's hear it for the parallelogram, so distinctive with not just one but two pairs of parallel sides. A rhombus with its 4 equal sides. A rectangle with 4 right angles. This is one special parallelogram. And a square. No mistaking this shape. 4 equal sides and 4 right angles. Not forgetting that trio of lovelies, the triangles. Equilateral with 3 equal sides and 3 equal angles. Isosceles, just 2 equal sides and 2 equal angles. And scalene, well, no equal sides here and no equal angles makes scalene unique.
Of course, if you look at shapes in the real world, they're not flat like the shapes in the parade. Let's take a look inside the shape of a building. Twist it and turn it, it takes up space. It's a three-dimensional shape. So that we can think about these real-life shapes, we often draw them simply. One face of the hotel can be drawn as a rectangle. Let's take a look at the world with a mathematical eye. What are the real-life shapes we find around us every day, and what's the math story we can find out about them? In real life, it's a window in a building. But look with a mathematical eye, and it's a square. In real life, it's a slot to post a letter. But look with our mathematical eye, and it's a rectangle. In real life, it's the grid at the bottom of a tree. But look with our mathematical eye, and it's an equilateral triangle. In real life, a gap in some block paving. But look with our mathematical eye, and it can be filled with an isosceles triangle. In real life, a bridge. But look with our mathematical eye, and it's a scalene triangle. In real life, we can see it's where two roofs meet. But look with a mathematical eye, and we can see it's a right-angled triangle. So, we can find the math story about a shape with our mathematical eye. And we can use our mathematical eye when we look at real life around us for a rectangle, a circle, a triangle. But some shapes in the real world are not easy mathematical shapes.
We interrupt this program to bring you an urgent newsflash. We've received reports from all over Britain that shapes are going missing in front of people's very eyes. Shapes like windows and doors are disappearing. Some people saw what happened and have come forward as witnesses to help the police. Oh no! Is nothing safe?
Look lively, look lively. You're supposed to know what happened. Right. Witness A. Witness B. Witness C, Witness D. Can you show us the shapes that you saw being taken away? Aha! A line, a B. May as well finish the job. B to C, another line. C to D, now this one's parallel to AB. And DA is parallel to BC. A clear case of a quadrilateral, not just any old quadrilateral, a parallelogram if ever I saw one. A photo, please. Thank you. What's that, Witness C? You think you're in the wrong place? Well, shuffle along then. So, Witness C has now shuffled along to form a trapezium. Best take another snapshot for the record. Have you four quite finished now? Oh, you all want to move. This had better be good then. We now seem to have a special rhombus. Indeed, a special rectangle. 4 equal sides and 4 right angles. A square. Looking at it sideways. One last photo, if you please. It looks like our 4 witnesses have seen all manner of quadrilaterals going missing.
The witnesses talked about the shapes as a series of points joined by lines. So, A, B, C, D are the points joined by lines to make a shape we haven't yet met. A trapezium. We can give the points any letters. We've seen P, Q, R, S before. What is it? It's a square. And what sort of shape would be missing here? Any 3 points will join to form triangles. So that's the case of the disappearing shapes. I wonder if they can ever be replaced. Stay tuned and we'll find out. Remember how we've been looking at the world with a mathematical eye? From some of the real-life shapes around us, we've been able to find mathematical shapes. So, from the real-life window, we found a square. But look hard enough at the square with a mathematical eye, and you might start to see yet more shapes inside it. The square is an explicit shape, but these triangles are implicit shapes. We found them using our mathematical eye. There are 2 implicit right-angled triangles in the square. Each one is an isosceles right-angled triangle. If you looked harder, you could find more and more right-angled isosceles triangles inside the square. Have a look for the implicit shapes in this real-life shape. If we look at the world with a mathematical eye, perhaps we can help out in the case of the disappearing shapes.
The hunt for the missing quadrilaterals goes on. With windows and doors missing all over the country, shapes have been called upon to fill in the gaps. Many are getting into shape to fit those gaps.
If you triangles are ever going to get it together to make up those quadrilaterals, there's some serious iron to pump. Isosceles, you were asking me, does my base look big in this? Frankly, my dear, yes. But at least the other 2 sides are looking equal now. Scalene, 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 it's just not working, is it? Every side different, every angle different. Just where is that symmetry? There's no gain without pain. Equilateral, you are a beauty to behold. Those rippling sides, both exactly the same, and that base, exactly the same as the sides. And your angles, they couldn't be more equal. Right-angled triangle. I can see you and your friends filling in those quadrilaterals rather well. Now don't wear yourself out. It could be a long day.
Implicit shapes are filling in for the quadrilaterals during the current shape crisis, with isosceles right-angled triangles filling the empty square, and the right-angled triangles filling in this rectangular space, and many like it.
Just how long will the crisis last? Will the explicit quadrilaterals return in our final instalment? Or will the implicit shapes just have to fill in forever?
The world of mathematics has been rocked this week by the disappearance of the quadrilaterals. Perhaps you noticed something happening at a building near you. Last pictured here on Sunday evening, police are appealing for information on parallelogram. Distinctive features are two pairs of opposite parallel sides, the opposite sides are equal, and the opposite angles are equal. Rhombus, often confused with parallelogram, but notice that all four sides are equal. That's how to tell it apart. And here's trapezium with just one pair, that's just one pair of parallel sides. So, have you seen these shapes roaming the streets? They should be easily identified. Do you have any information about them? Remember, not all shapes are bad, so don't have nightmares.
News just in after asking for you, the viewers, to help to identify the missing quadrilaterals. There's been a breakthrough and they are being returned. Four-sided shapes are reappearing all around the country. One viewer from the Midlands commented,
"Well, it was really horrible. I came back to park my car and the driveway had completely gone. I'm glad they're back. I'm really glad they're back. Could we tell anybody?"
A spokesperson for the triangles said,
Well, the triangles are very relieved the explicit quadrilaterals are back. We know there are implicit triangles in all quadrilaterals, but we just couldn't keep up with demand, and Scalene was really put under terrible pressure to fit in.
Well, with all the shapes back in place, take a good look around you for explicit quadrilaterals. They will be there. They're all around you. And keep your eye open for explicit triangles too. Oh, and while you're looking, don't forget to try out your mathematical eye and see what implicit shapes you can imagine within the quadrilaterals around you.
Ladies and gentlemen, to celebrate the successful return of the disappearing shapes, we have collected together all of your favourites for a final guest appearance.